Hello, calculus fans. Let's talk about some properties of vectors. Let's suppose we have vectors u, v, and w, and they're n-dimensional vectors. So we'll pose it as n-dimensional vectors. That way, this works no matter what dimension you're using. And let's say a and b are scalars. Then we have a whole bunch of properties of vectors. Now, I'm just going to list them all. I wouldn't say that these are properties that you need to have memorized, just sort of get used to them. So without going through these in gory detail, the second property here, that's an associative law. It says that when you add vectors, it doesn't really matter which order you add them. Property 5, that's a distributive law. You can distribute scalars across a sum. Other properties that I think are fairly obvious. Property 4, if you take a vector and add its negative, then you get the zero vector. Okay, so all these properties are important, but I don't think that you have to memorize them. And you certainly don't need to memorize the property numbers or anything like that. Nobody's ever going to ask you, well, which property did you use? Is it property 4 or property 5? No, that's sort of a crazy question to ask. Now, there are 3 particular vectors in R3 that play a very special role. These are the vectors 1, 0, 0, 0, 1, 0, and 0, 0, 1. And they're so special that we give them names. We're going to call them I, J, and K. All these vectors have length 1, and they point in the direction of the positive x, y, and z axes. Now, in 2 dimensions, we'll call I the vector 1, 0, and j is the vector 0, 1. There is no k in 2 dimensions. So if u is the vector that has components a1, a2, a3, then what we'll write is that u, which is a1, a2, a3, we'll break it down as the sum of these 3 vectors, a1, 0, 0 plus 0, a2, 0 plus 0, 0, a3. Each one of those vectors will factor out the a's. And now what you see that's left over, those vectors, those are the special vectors that we talked about earlier. And so we finish by saying that this vector can be rewritten as a1i plus a2j plus a3k. So what we know now is that any vector in R3 can be expressed in terms of what we'll call the standard basis vectors I, j, and k. If you've studied linear algebra, then this phrase should be familiar to you, the standard basis vectors. For example, I could take the vector who has components 2, negative 3, and pi, and write that as 2i minus 3j plus pi k. So from now on, I think you should just be used to going back and forth between these 2 notations, and we'll use them together freely. So in 2 dimensions, we'll write that v, which is equal to a1, a2, we'll write that as a1i plus a2j. Okay, that's all for now.